The friction chapter, let us first take this problem, which is actually number 4 and 5 in your textbook. It says that a block of mass 4 kg slides down an inclined plane of 30 degrees. So to start with, let us draw this diagram. Block of mass 4 kg. This inclined plane is 30 degrees and block of mass 4 kg. Also says that starting from rest, it covers 8 meters in 2 seconds. So it says, but this body has an acceleration A. Right? Now, they ask us to find the coefficient of kinetic friction. So for this kind of a problem, rather this is true for the entire chapter of friction, we have to first find out the component of forces. Component of gravitational attraction is mg, which acts vertically down. Now, find two components of mg, one perpendicular to the plane, another horizontal to the plane. If this is theta, then this angle is also theta. This force is always mg cos theta. It's always mg sin theta. There will be a reaction force, R. In this case, since there is no other vertical component of the force, so R equal to mg cos theta. So we can already write this, that R equal to mg cos theta. Since the body is going downward, so there is an upward frictional force along the slope. This frictional force is F, right? And we also know that F is always equal to mu reaction force. In this case, F is equal to, therefore, mu reaction force has to be equal to mg cos theta. So mu m, this is mu mg cos theta. Fine. Now let us find the acceleration A. Let us find acceleration A. You can easily find it from the equation, kinematic equation, S equal to ut plus half A square, from this equation. But S is given 8 meters and time is given 2 seconds. So from here we get 8 meters is equal to U is the initial velocity is 0 plus half A into from here we get A is equal to 8 by 2, that is 4 meters per second square. This is one value which has to be remembered. Next is The body is moving downward along the slope. What are the forces along the what forces downward along the slope? The force which is downward along the slope is mg sine theta, that is this force, and the force is upward along the force is F, which is equal to mu mg cos theta. So this force minus upward force theta will create the acceleration A. So mass into acceleration A, which is equal to 4m. 4 into mass m. Now, from all this mass m, this mass m, and this mass m gets cancelled. So we have g sine theta minus mu g is equal to 4. From here, we get what is mu. Mu is g sine theta minus 4. That is g sine theta minus 4 g cos theta. Now we know theta is equal to 30 degrees. So we know the value of both sine theta, cos theta. So it is g. Let us write the value of g. G is half. G is 10, sorry. 10 multiplied by sine theta is 1 by 2 minus 4. And this g is also 10. Cos theta is equal to root 3. Theta equal to root 3 by 2. So this 2 and 10 gets cancelled. We have 5 here. This 2 and 10 gets cancelled. We have 5 here. So what we have, 5 minus 4 is equal to 1. And in the denominator, we have 5 root 3. Calculate this, you will find value of the frictional force mu 1, 1, 5. And mu doesn't have any unit, so it is 0.115. Now there is a second part of the question. How far will the block move if the inverse to then suppose the block is pushed down by an incline with the force of 4 Newton. In a new situation, there is an additional 4 Newton force. That means it says that in the new situation, the block is here, and there is an additional F is equal to 4 Newton additional forces applied. How far will the block move in the first cruise? That means you have to first find out the acceleration. Right? There is an additional 4 Newton force. Now, and also it was given that the mass of the body is 4 kg. In the first part, we did not consider the mass 4 kg because m finally got cancelled. Mass of the block is 4 kg. So here, the downward gravitational force is 4g. The Normal component of the gravitational force is 4g cos theta, and the component of the gravitational force parallel to the slope is v sin theta, and the reaction, of course, is equal to the, the, the opposite force. This is equal to 4g theta. Now there is a additional, now there is a frictional force F. This frictional force in this case, frictional force F is equal to mu R is 4g cos theta, right? And this force, frictional force, you can see it is upward along the slope. What are the forces down the slope which is create acceleration? We consider forces on the forces down the slope is equal to one force is 4g sin theta, another force is this 4 Newton applied force. So 4 plus 4g sin theta. In that case, the total downward force, that is 4 plus 4g in theta, minus the upward force small f, it is mu 4g cos theta, will create the acceleration of the 4 kg mass. Right? Here, we find that the mass gets cancelled. So what we have 1 plus g sin theta minus mu g theta is equal to A. From here we can get, so acceleration A is equal to 1 plus g is 10, sin theta is 1 by 2, sin theta is 1 by 2 minus mu has been found earlier to be 1 by 5 root 3. So from here, the mu comes here, 1 by 5 root 3, by 5 root 3, multiplied by g is 10, cos theta is root 3 by 2. Find here, we find that it is 2, 10 makes 5, and here also this root and root 3 gets cancelled, and 2, 10 makes 5, and this 5 and 5 finally gets cancelled. It is equal to 1 plus 5 here minus 1 here is equal to 5 meter per second square. So this is the acceleration. But they have not asked for the acceleration. They have asked how far the block will move in 2 seconds. Look that in first case, when there was no external pushing force, the acceleration was 4, now acceleration is 5. How far will it go in first 2 seconds? Again, use the formula S is equal to U T plus half acceleration into T square is equal to 0 plus half acceleration is now 5 into T square is 2 square is equal to 10. So the answer to the second part is answer to the second part is 10 meter, right? So we start now and shall go to the next problem next.